Section 4.3 talks about more discrete probability distributions. So the first one we're going to talk about here, guys, is something called the geometric distribution. And it says a geometric distribution is a discrete probability distribution of a random variable x that satisfies. We got four conditions here. It says a trial is repeated until a success occurs. Repeated trials are independent of each other. The probability of success P is the same for each trial, and the random variable x represents the number of trials in which the first success occurs. So it says the probability that the first success will occur on trial x is, and we have a formula right here, and it says P of x is going to be equal to P to the power, or times Q to the power x minus 1, where Q is equal to 1 minus P. Okay, so let's see if we can figure this one out. We'll go to the first problem, and it says basketball Tony Parker makes a free throw shot about 80% of the time. Find the probability that Tony makes his first free throw shot on the third or the fourth attempt. So there's really two questions here. One of them is what's the probability he's going to get it on the third attempt, and the other one will get it on the fourth. Okay, so first let's find the probability that he's going to actually make a free throw shot. Well, it says it happens 80% of the time. So as a decimal, guys, that's going to be 0.80. Q would be the probability that he does not make it. So if he makes the shot 80% of the time, that means that he misses it 20% of the time. So Q, the probability that he doesn't make it, would be 0.20. So I'm going to go ahead and start writing out my problem. The probability he's going to make it on his third attempt, and I'm just using this formula right here, is going to be equal to 0.80 times 0.20 to the power x minus 1. X here is 3. I'm actually going to write 3 minus 1, and I'll put it in parentheses. And then we'll do the same thing for the fourth attempt. Okay, so 0.80 times 0.20 to the power 4 minus 1. Now the reason why I'm writing this out, number one, I want to make sure that we know how to use the formula. Number two, I'm going to show you how to do this on my calculator. Move this over here. Let me turn it on. And okay, let's clear it out. So first thing I'm going to do, I'm going to put parentheses because I got them. 0.80, close it off, times 0.20, close it off, okay, to the power. Look what we have. We have 3 minus 1, close it off, hit enter, and I'm coming up with 0.032. Okay, so there's my answer for the first one, 0.032. Now let's do the same thing for the second one. So guys, just a little calculator trick. Again, guys, the calculator I'm using here is the same thing as the app. The steps are exactly the same. So I'm going to hit second and then the enter button because there's the little word entry right above it. And it types in exactly what I had before. And I'm going to change that 3 minus 1 to a 4 minus 1. And hit enter, and I'm coming up with 0.0064. Okay, 0.0064. Okay. All right. Problem number 2 is exactly the same as problem number 1, except now we're looking at on his first or second attempt. So on his first attempt would be 0.80 times 0.20, 1 minus 1. And second attempt would be 0.80 times 20 to the power 2 minus 1, okay, in parentheses. So let me get my calculator again. Here we go. Okay, let's go second and entry. And let's change that 4 minus 1 the first time to a 1 minus 1. Hit enter, and I'm coming up with 0.8. Okay. And we'll do it again. Second, enter. I'm going to change that 1 minus 1 to a 2 minus 1. Hit enter, and we're coming up with a 0.16. Okay. Alrighty, let me keep scrolling down here. Now we have something a little different. We have something called the Poisson distribution. It says a Poisson distribution is a discrete probability distribution of a random variable x that satisfies. Number 1, the experiment consists of counting the number of times x an event occurs in a given interval. This interval can be an interval of time or area or volume. Okay. It says the probability of the event occurring is the same for each trial. The number of occurrences in one interval is independent of the number of occurrences in others. The probability of exactly X occurrences in an interval. And we have a formula right here, guys, but we're actually going to use a feature on our calculator, and I'm going to show you how to do that right now. Okay. So let me show you how we're going to do this. Let's take a look at the problem number 3 here. Oops, let me scroll up just a little bit. And it says the mean number of accidents per month at a certain intersection is 3. What's the probability that in any given month 4 accidents will occur at this intersection? Okay, so remember we used the symbol mu to talk about the mean? So in here it says the mean of accidents per month, right? There's my interval, is equal to 3, okay? X is going to be the number of accidents that we're interested in. We're interested in finding the probability that in any given month 4 accidents is going to occur, okay? So what I'm going to do, guys, on my calculator, I'm going to use something called the Poisson Cdf, okay? And if you notice, the first number is going to be my average, and the second number is going to be the particular number of instances we're looking at. So in this case, I'm going to put 3, 4, okay, because my average here is this, and there's my X number. I'm going to grab my calculator. Let me clear this out. I'm going to do this. I would do it exactly the same way, guys, if I was using my app, okay? So I'm going to go to second, and I'm going to hit that little vars button. Because if you look right above the vars, do you see it says DISTR? That's distribution. And I'm going to scroll down. And keep going until I see one Poisson Cdf. Here we go. I see it's number 8. So I'm going to hit enter. And the first number I'm going to hit is 3, comma. Second number I'm going to hit is 4, comma. Close off my parentheses. I'm going to hit enter. And so the probability I'm coming up with here is 0.1680. 0.1680. Now, guys, I put 4 decimal places here. For the most part, I'm probably going to go with about 4. When you're doing your homework, if my math lab tells you to go to 3, then go to 3, right? But I'm just going to be writing up 4 here. Okay? Now, let's take a look at number 4. Number 4 says, what is the probability that less than 4 accidents will occur in any given month at the intersection? Okay, if we're looking for less than 4, think about what that means. That means that we want to have either no accidents, or 1 accident, or 2 accidents, or 3 accidents, right? Because we want to have less than 4. So it would be 3 or less, right? Now, we could do the same thing that we did right here, the Poisson Cdf, right? We could do this, and we would have to do it 1, 2, 3. We'd have to do that 4 times, right? And then we would take each of those numbers and we would add them all up. Well, instead of doing that, there's something called the Poisson Cdf. What the C stands for, guys, is cumulative. Remember what cumulative means? We're going to add them all up. So when I do this, remember in here, my mean is still 3, right? Because the number of accidents was 3. That's what we knew about that, right? And now my X number is going to be the biggest number that I would use, 3. And what it's telling me is it's going to do this calculation here for me, okay? So I'm going to grab my calculator again, okay? Move it over a little bit. Here we go, just so you can see what it is I'm going to do. And I'm going to go second, and I'm going to go vars because I want that distribution feature. I'm going to scroll down, okay? And I'm looking for Poisson Cdf, right? Cumulative. So I'm going to hit, this looks like it's part C or whatever it is right here. So I'm going to hit enter. Oops. Okay, second vars. I tapped it too many times. Here we go. Enter. Okay, and now I'm going to hit 3, comma 3. Close off my parentheses. I'm going to hit enter. And I'm coming up with 0.6472. Okay, so 0.6472. Okay. All right. Let's take a look at number 5. Number 5 now says, what's the probability that 4 or more accidents would occur in any given month? So think about what that means. We want to have 4 or more. That means we could have 4, or we could have 5, or we could have 6, right? My question is, would I ever stop? I wouldn't, right? Because it says 4 what? Or more. So this would have to actually go on forever. Now, guys, one of the rules about probability is if, like I told you, I'm going to kind of do a little side note over here. So let me just move this over to the side so you can see what I'm talking about. Suppose I told you that the probability that it was going to rain today, right? We're watching Tim Smith, and Tim Smith says, hey, you got to know where you live on a map. And the probability of that it's going to rain in La Villa is going to be 70%. And then you would say, well, what's the probability that it's not going to rain? Well, then we would say we're going to take 100% minus 70%, and that'd give me 30%, right? Or I could do it without percentages. I could do it by saying, let's take 1 for 100% minus 0.70, because that's what 70% would be as a decimal, and I'd end up with 0.30, okay? So when I know the probability of something is going to happen, the probability that it will not will be 1 minus whatever we got the first time, right? So the reason I'm bringing that up is when I come back over here, right, and we were looking for the probability that we're going to have 4 or more, which was 4, 5, 6, so on and so forth. We could say, well, that's going to be the same thing as 1 minus the probability that we're going to have less than 4, right? And isn't that what we found in problem number 4? We found the probability that it was going to be less than 4. So now we can say, let's just take 1 minus 0.6472, and I'll do this on my calculator again, okay? And so I'm just going to type in 1 minus 0.6472, and I'm coming up with 0.3528, okay? Now, guys, again, one thing I want to mention, the reason why I was doing it this way is because here I would never stop, right? I couldn't stop at 8 because it's possible there could have been 9 or 10 or 11, right? So I really needed to do it like this, okay? Alrighty, let me keep scrolling here. And it says a population count shows that the number of rabbits per acre living in a field is 3.6. Use the table to find the probability that 7 rabbits are found in any given acre of the field. Okay, so look what they're telling me. They're telling me that the average is 3.6. Remember, the mu is the symbol that we use for our average. It's 3.6. So I'm going to look at this part. And we're trying to find the probability that we're going to have how many rabbits? 7 rabbits. So now I'm going to do this number. And those two sort of lines intersect at 0.0425. And there's my probability. Okay. Alrighty. Taking a look at the next problem here. It says, a mail order company receives an average of 5 orders per 500 solicitations. Okay, if it sends out 100 advertisements, find the probability of receiving at least 2 orders. It says use the Poisson distribution. Okay, so if we have an average of 5 orders per 500 solicitations, wouldn't that mean that we get 1 order per 100 solicitations, right? Guys, solicitations is just another word for advertisement, okay? So in this case, I know my mu It's going to be equal to 1, okay? And we're going to use our Poisson distribution. We want to get the probability of having at least 2. Oops. At least 2. So remember what that means. That means I want to have the probability of 2, or the probability of 3, or the probability of 4, and we could keep going on, right? So if I want to see how can I find this, because I'm never ever going to be able to stop, right? I can't stop at 4. I can't stop at 5. I have to keep going. One way we can do it is we can say, well, let's find 1 minus the probability that we have less than 2. Well, less than 2 would mean 1 minus the probability that we don't get any, or we only get 1. Okay. So I'm going to do this using my Poisson Cdf with my average being 1, because we said that's our average. And if I want 0 and 1, then the top number is going to be 1 as well. Okay, so I'm going to go 1 minus Poisson Cdf of 1 comma 1. Okay, 1 minus, let me grab my calculator, it is right here. Okay, so I'm going to go second, vars to get my distribution, scroll down, Poisson Cdf, enter 1 comma 1, close it off, and that's coming up with 0.7358, 0.7358, and then if I just do 1 minus that answer, 1 minus my answer, I'm going to come up with 0.2642. 0.2642. Okay. All right. So we got a couple more problems here. Let's see if we can't figure these out. And it says, the first one says, or the directions say, in these problems, find the indicated probabilities using either geometric, Poisson, or binomial distribution. Then determine whether the events are unusual. If convenient, use the table of technology. So guys, we're going to be using either the calculator or the calculator app to do these problems here, right? It just makes it so much easier to do. Okay, so it says the probability that you'll make a sale on any given telephone call is 0.19. Find the probability that you're going to make your sale on the 5th call. Let's just do that part first, okay? So now, what I got to figure out, is this going to be geometric? Is it going to be Poisson? Or is this going to be binomial? Okay, it's going to be one of these three. Okay. So look what it's telling me. We're going to make our sale on the 5th call. So if I scroll back up, I'm going to scroll. Here we go, 4.3. This problem here, guys, is very similar to the one about Tony Parker. Because it says, look, find the probability that he makes his first free throw on the 3rd or the 4th attempt. Okay. So geometric says we're going to keep trying this, and we're going to find the probability that the first time you succeed is on this time, like this attempt. Okay. So I'm going to come back over here. We're going to say this is going to be geometric. Okay. So if it's geometric, my formula, guys, is going to look like this. Okay. So first thing we're going to do, we're going to find the little letter P, meaning the probability that we make a sale. So the probability we're going to make a sale is going to be 0.19. So the probability that we're not going to make a sale is going to be 1 minus 0.19. Okay. That's giving me 0.81. Okay. So to do part A, we're going to make our first sale on the 5th call. So this is going to be the probability that the first time we get this, it's going to be on call number 5. So I'm going to go 0.19 times 0.81 to the power 5 minus 1. Okay. So get parentheses here, 0.19 times 0.81 to the power 5 minus 1, that's just going to give me 4. Power of 4. Here we go. And again, I'm going to go to 4 decimal places, so 0.0818. Okay. Let's do part B. Part B says we're going to make your first sale on the first, second, or third call. Okay. First, second, or third call. So let's find the probability we get on the first. Okay. So on the first, it's going to be 0.19 times 0.81 to the power 1 minus 1. Probability I'm going to get it on the second is going to be 0.19 times 0.81, 2 minus 1. And the probability I'm going to get it on the third is going to be 0.19 times 0.81, 3 minus 1. And what I'm going to do is I'm going to add each of those numbers up. Okay. So let's do this. Second entry. Okay. But the first time, 1 minus 1, that's going to give me a 0. So instead of a power 4, I'm going to put a power 0, and I'm coming up with 0.19. Okay. So far we have 0.19 plus, we're going to do that again, second entry. Okay. Now notice the power here, 2 minus 1. 2 minus 1 is 1. 0.1539. Okay. And we're going to do this a third time. Second entry. Okay. And let's see, 3 minus 1, which is what I have right here. 3 minus 1 is 2. Enter. I'm still going to go to 4 decimal places. 0.1247. 0.1247. Okay. And now I'm just going to add those numbers up together. So let's go 0.19 plus 0.1539 plus 0.1247 is 0.4686. Okay. And we have a part C. We do not make a sale on the first 3 calls. Okay. We do not make a sale on the first 3 calls. So part C is no sale on first 3 calls, right? So guys, if you notice, what we did in part B was we found the probability that we would get a sale on our first, second, or third. So now when it's saying what's the probability that we won't, we can just take 1 minus the answer that we got from part B, 0.4686. And so again, if I take my calculator, 1 minus, let me do this again, 1 minus second answer, I'm coming up with 0.5314. Oh, what's going on with my pen? Sorry guys, my pen seems to be freezing up. There we go. 0.5314. And there is my answer for part C. Okay. So, okay. All right. Now, let's do the next problem. It says migrants. The mean number of international migrants gained per minute in the United States in a recent year was about 2. Find the probability that the number of international migrants gained in any given minute is exactly 5. Okay, so we're looking for the probability we're going to get exactly 5. So I want you to notice here, the mean number of international migrants gained per minute was about 2. So this is telling me that my mu is going to be equal to 2, right? So when we have an average, it's over an interval of time, area, or volume, this is going to be Poisson, right? Okay, so let me come back over here. Okay, so we know our mean is 2. And in part A, x is going to be 5. So I'm just going to go Poisson PDF with my mu being 2 and my x value being 5. So let me clear this out, right? Remember, guys, second and vars, because I want to get to the distribution. And I want to go to Poisson PDF. Here we go. With my average being 2 and my x value being 5. And I'm coming up with 0.0361. 0.0361. Okay. All right. Part B, that was part A. Part B says at least 5. Remember what at least 5 means. At least 5 means I want it to be 5 or 6 or 7, so on and so forth, right? So because I'm never going to end here, what I need to do is I need to say, well, how about we do 1 minus the probability that it is less than 5, okay? So the way I could do that is I could say 1 minus the probability is going to be less than 5 would be Poisson Cdf with my average still being 2. And if I want it less than 5, remember what less than 5 means. It means it's going to be 0 or 1 all the way to 4, because it has to be less than 5, okay? So I'm going to do it like this on my calculator. So let me grab my calculator. Guys, first thing I'm going to do, I'm going to do this part here. So we're going to go second vars. We're going to scroll down, to Poisson Cdf. There we go. I'm going to use 2, 4. Okay, enter. And then I'm going to go 1 minus that answer. Okay, which in this case is 0.0527. Okay. And then there is a part C, more than 5. Remember what more than 5 means. More than 5 means what? 6, 7, 8, so on and so forth. So this is very similar to part B. And then I'm going to do, okay, 1 minus the probability that it is less than 6, right? Because I want it to be more than 5. So the same thing, more than 5 means 6 or bigger. Okay. So this is going to be 1 minus the probability of 0, of 1, right? All the way to what, 5? Okay. So now I'm going to go 1 minus Poisson Cdf, still with my average being 2, but now my x value is going to be 5. Okay. So doing this on the calculator, we're going to go second vars. We're going to scroll down. Here we go. My average is 2. My x value is 5. Okay. And then I'm going to go 1 minus my answer. And I'm coming up with 0.0166. 0.0166. Okay. 0.0166. Okay. Here we go. Alrighty. So now, let's take a look at the last problem we got here. And it says fracking. 51% of U.S. adults oppose hydraulic fracking as a means of increasing production of natural gas in the United States. You randomly select 8 U.S. adults. Find the probability that the number of U.S. adults who oppose fracking as a means of increasing production of natural gas and oil is A, exactly 4. Okay, so we're looking for the probability it's going to be exactly 4. Okay, so we're going to figure out what kind of is this going to be. Remember we already picked geometric. We've already used Poisson, so now this is going to be binomial. So binomial we actually did in 4.2. So I'm going to scroll back up here, and we're going to figure out how do we do this in 4.2. Okay, but we did it using our little formula. Here we go. So remember, I'm going to highlight it right here first so we can see. So binomial PDF will have the number of trials, then our probability, and then our x value, right? So, oops, let's come back down here. There we go. Okay. So this is, we're going to go binomial. Oops. Binomial PDF, right? The number of trials. So number of trials, number of adults was what, 8? Okay. My average here, oh, I'm sorry, the probability was 51%, so 0.51. And then our x value is 4. Okay. So let me grab my calculator here. Second vars. We're going to go to binomial PDF. There we go. Number of trials was 8, comma, 0.51, comma, 4. Hit enter. And I'm coming up with 0.2730. 0.2730. Okay. Part B, less than 5. Less than 5. Okay. So less than 5 is going to be 0 and 1 and 2 and 3 and 4, right? So here, guys, we can actually go binomial Cdf with still 8, still 0.51, and we went up to 4. Okay. So I'm going to do the same thing we did before. We're going to go second vars. We're going to scroll down here. Oops, binomial Cdf, past it. There we go. Enter. And I'm going to go 8, comma, 0.51, comma, 4. And I'm coming up with 0.6146. 0.6146. And then part C says at least 3. Remember what at least 3 means. At least 3 means 3 or 4 or 5, right? Or 6 or 7. Here we'd actually stop at 8 because we're only selecting 8 adults, right? So we could actually do each of those individual calculations and add them up. Or we can say, why don't we do 1 minus the probability that we have less than or equal to 2, okay? And I could say, well, I could do that by using my binomial Cdf with 8, comma, 0.51, comma, 2, okay? So let's go second and vars. We're going to go to binomial Cdf. There, enter, and 8, comma, 0.51, comma, and 2, comma, or close parentheses, sorry. And then I'm going to do 1 minus that. 1 minus my answer. And I'm coming up with 0.8682. 0.8682. Okay. And that right there, guys, was the end of 4.3.